Bright Cutie. Every student matters.
On the basis of this right hand rule, we form the principle of electric generator, or we call it a dynamo. Now, this dynamo or electric generator works on this principle. Which principle? That when a wire or a metallic wire is moved in a magnetic field, a current is induced in the coil, in the wire. A current is induced in the wire. Right? This is the principle of electric generator. Now, we will see how we generate electric current or induce current in a wire. This is the setup of a generator. First of all, try to relate. We have already done the motor part. It is 99% same to that of electric motor. Let us try to compare. In that motor, we will be revising both the things simultaneously. We had this north pole and south pole, a magnetic field, that was horseshoe magnet provided. There was a rectangular coil A, B, C, D. 4 corners we have taken. Then with this part, we have connected these split rings. These were the same as were there in the motor. There are B1 and B2 carbon brushes, just like same, attached to these split rings R1 and R2. Right? Now, the change is that over there in a motor, we had connected this wire with a cell or a battery, but here we have connected it with a galvanometer. Right? Fine. This galvanometer will detect the presence of current. Fine. So, I hope you have understood the construction part of a generator. Right? This is a north pole. This is a south pole of a magnet. Inside the magnet, we have taken a rectangular coil A, B, C, D. These coils are connected with these split rings or commutators. These are called. These are split rings, broken rings, right? These split rings are connected to brushes, carbon brushes B1 and B2. Now, try to relate, please. Initially, this was the first case. Initially, this side A and B, right? This side AB is connected with this split ring R1, and this R1 is connected to carbon brush B1. I try to highlight A and B side is connected with split ring R1 connected with B1. Right? Similarly, this side CD, the side CD is connected with this split ring R2, and this in turn is connected with carbon brush B2. Got it? Now, what we will do is we will rotate this particular coil. Now, when I will rotate the coil, I can do it anti-clockwise or clockwise, my wish. I am doing it anti-clockwise, means this AB side is going in the downward direction and the CD side is coming in the upward direction. Now, please try to relate with my hand movement. Try to relate with my hand movement. Let us see. For example, this is basically the side AB and this is the side CD. What I am doing is I am trying to just flip it over like this. I am trying to move this side AB in the downward direction and the CD in the upward direction. Right? Fine. Now, just try to relate this side AB. Right? This side AB is going in the downward direction. Means the force on this side AB is in the downward direction. The magnetic field lines, as we can see, this is north pole, this is south pole. So the magnetic field lines will be going from north to south. Now applying the right hand rule I will see that this particular magnetic field lines, they are going in the southward, north to south direction, and the force on the wire is like this, in the downward direction on the side AB. So applying this rule, I will see that the current, the direction of current is towards me. That is, it will be from B to A. We'll just see in the diagram, right? And if we take the opposite, that means once again we take the side CD. This side CD is moving up. The magnetic field lines are again north to south. Now if I apply right hand rule to find the direction of induced current, what I will do is, this is in the north south direction, my forefinger is pointing. Now this is in the CD, this is the direction in which force is applied, upward, and this will be the induced current. Now the induced current is in your direction, that means it will go from D to C. Now come to the diagram and try to relate, please. In this side AB, we saw that the current is coming in this direction. Please try to relate that direction. This was the wire AB. The direction of current is like this. How did we get it? This is the direction of current. How do we get it? We get it by applying Fleming's right hand rule, right? And in the side CD, this is the side CD. In this side CD, which is moving, motion is in the upward direction. Now the direction of current is shown by this arrow. That means it is going from D to C. Now please try to relate this D to C. If the current going is in this direction, it will be going D to C, then to B, and then to A. From this A, it will come to this split ring R1. This split ring R1 is attached with this B1. So the from this carbon brush B1, the current is going in this direction. So the B1, which was with AB and R1, it is positively charged now. It will have the positive charge. This particular current will travel. Please relate the direction of current with the arrows, goes to the galvanometer, positive and negative, and this comes like this. From this B2, this B2 becomes negatively charged. This goes to R2, and through R2 it goes from D to C. This will be the direction of current moving along. Now very importantly, fine, once this one turn is over, now what will happen is, it will altogether change. How? Let us rub it off and let us try to relate right from the beginning. Please try to relate now. Once I have just rotated this wire, now this side C and D, which are along with R2, fixed it up with R2, they will come to this part. Now this will become CD part, and the AB side will rotate, and they both will change their positions. So now we will have R1 here and R2 here. So now what will happen is, very importantly, try to relate. Now after one rotation, the second case is that AB and R1 split ring are now attached to B2 because they have changed their sides. The carbon brushes B1 and B2 are fixed, but R1 and R2, they will change their positions as per the wires and as per the sides of the wires. And now the wire CD, which was connected to R2, will now come to B1. Now this particular side, whichever is in this side, initially it was AB, now it is CD, it is going in the downward direction because we are moving it that way only. Now what will happen is, in this CD, the current once again will flow in the downward direction, and through this R2 it will come to B1, and from this B1 it will move ahead. So once again the B1 will become the positive terminal now, and B2 carbon brush is the negative. Right? Getting my point? Again, if you will once again come back to the first after rotation, This AB and R1 will connect to B1, CD and R2 will connect to BT, B1 will remain positive, B2 will be negative. How many rotations, whatever you will take, every time you will find that this B1 is always positive here or here, B2 is always negative. So the direction of current, very importantly, please try to remember it because I am going to relate it in the further topic. The direction of current is always from B1 towards B2. B1 is always the positive terminal, B2 is always the negative terminal, and the direction of current remains the same. And this type of current in which the direction always remains the same is known as direct current. So what is direct current or DC? Direct current is that current which has the same direction, which does not change its direction. That is direct current, right? And how we can relate that it is direct current? That in this setup we saw that the carbon brush B1 was always at the positive terminal side and B2 is always negative, because every time we rotated the coil, these split rings changed their positions, right? Try to relate. When AB was here, the current was going in the downward direction. When AB was here, the current was going in the upward direction. So the direction of current was changing in AB, but it was mitigated, it was compensated, because when the direction of current was in the downward, this AB was with B1, but when it got opposite, the side AB also changed its terminal to B2. That is why there was no problem whatsoever, and this is the direct current. And this particular setup in which we just induce direct current is known as DC dynamo या DC generator or DC direct current generator. Correct? Fine. Now what we do is we just make a little bit of change. Please try to relate, otherwise it may get confusing for some students. The same setup we will take the same N and S, the magnetic field. We'll take a same ABCD, a rectangular coil. We will take the same B1 and B2, the carbon brushes, but now there is a difference. This R1 and R2, now instead of taking split rings, now we have taken slip rings. Now this will create a lot of difference. When I am talking about these slip rings means even when the coil gets rotated, right, the sides AB, they will always be fixed with this split ring R1, and the side CD is always going to be just with this slip rings R2. So now it will be altogether different. Once again connecting it with a galvanometer. Now try to relate, students. I hope you are getting what this particular thing is going to mean. Let me try to explain the things and please try to understand. When we rotate the coil, fine, this AB, this is the first case I am taking when the AB is on the left hand side, right? When I will rotate the coil AB, then as per the right hand rule, we saw that the current was coming in the downward direction. Now this AB is fixed up with R1. This R1 is with B1 carbon brush, as we can relate in this diagram, right? Fine. And the side CD is attached to slip ring R2, which is turn is attached to B2 carbon brush. This is the carbon brush B2. When in the first case AB side is going down, current is produced here from B to A. Because of this B to A, the R1 and the B1 becomes positively charged and the current flows like the same it did previously. So B2 will become negative charge. But importantly, when one rotation is over, in the second case, after the rotation is over, now importantly, AB has gone to the other side. Now this has become AB and this has become CD. Now what will happen is that in AB, the current will be going in the upward direction and in CD, it will be going in the downward direction. But the problem is that AB along with this R1 is still attached to B1 because of this slip ring. Right. Now the slip rings do not allow the AB to change the carbon brushes from B1 to B2 and B2 to B1 again. That is the main difference. And the CD which is attached to R2 is still attached with B2. Because now this CD has come this side and because now the current is coming in the downward direction, now what will happen is this B2 will become positive terminal and B1 will become negative terminal. This is quite important and this is the important difference. Fine. Once again, after one more rotation, the normal situation AB will come in the left, CD will come in the right. Once again, we will find this kind of setup that B1 will become positive, B2 negative. After half rotation, we will see again that B1 will become negative and B2 will become positive. So we see that after every rotation, we find B1 turning to positive, then to negative, again positive, negative, again positive, negative. So the direction of current will be from B1 to B2 and after one rotation B2 to B1, then B1 to B2 and then B2 to B1, it will continuously change its direction. Such a type of current, very importantly, is known as alternating current, which is represented as AC. Alternating current. What is alternating current? It is the type of current which changes its direction continuously. This is alternating current. And this kind of this setup in which we have generated this alternating current, this is known as AC generator or AC dynamo. Right? So AC and DC, these are the two types of currents that we can induce. Direct current DC, alternating current AC. Direct current doesn't change its direction, whereas alternating current changes its direction. Right? Fine. Now, whenever we transmit current over long distances, we prefer alternating current. Why? Because this alternating current, when we transfer it in this form, then there is very minimal loss of current. And because current is very important, electricity for us, right? That is why we prefer that there should be minimum loss of current, and that is why this AC is preferred for long term current transmission. This is quite important. This is the advantage of AC over DC. Got it? One more thing that you need to relate. One thing is, nowadays it has become quite important, that is armature. You need to know what is an armature. What we do is we just take, for better magnetism and electromagnetism, we take soft iron core material and over that we just fix the coil over this soft iron core material. We wind the coil over this soft iron core along with this coil. This is known as armature, and that this increases the strength of the magnet and the current induced. Right? So what is armature? What is the function? You need to remember separately. Got it? This is all about our motor, generator. In this generator, AC generator and DC generator. Got it? These are very important. Out of these three, you may be asked any one along with diagram. So you need to practice the diagrams with labelings properly. And in AC and DC, we saw that the most important one thing that created all this difference was in DC we got the split rings and in AC we got the slip rings. That is the main reason why we get these different types of currents. Got it? Good. Now, in our houses, okay, let us see one more activity. What we perform over here is we will take a coil A, right? On this coil A, we just take an inner soft core any material, right? And then after winding this particular wire, we connect it to a kind of cell or a battery. Now we take another coil B. In this coil B, we just took the south and any core material, wind the wire over it and connected it to a galvanometer. Fine. When I will switch this particular coil A's current on, fine, I will find a very nice observation. I will see that there is a deflection in the galvanometer of coil B, even though there was no current to start with. There was a kind of deflection for some time and then the galvanometer will return to zero. Now this deflection in the galvanometer, it suggests that when current was passed in this coil A, there was a magnetic field created because of the magnetic effects of current. Now that magnetic field which was created here, because of that some current was induced in coil B2, because of which the galvanometer showed a deflection for some time. Right. Now importantly, when I will switch it off, now there is no current in coil A, but again I will find some deflection momentarily for a few seconds. I will find, or rather for a fraction of second, I will find a deflection in this galvanometer again. Now this activity tells us that whenever there is a change in the magnetic field around any coil, current is induced in it. This coil A, which was actually connected to a cell, this coil A is termed as primary coil. And this coil B, it is termed as secondary coil. So this is an activity which basically shows to us that current can be induced in a coil by changing the magnetic field around it. Got it? Fine. Primary coil and secondary coil.